So let's officially start this session. So I am suppose that everyone has done some background work required for today's session. I guess let me share my screen, or yeah.
You don't have right now. Don't share your screen. Just a second.
Okay, fine. Okay, fine.
Okay. I'd like to welcome a new member of our teaching team. His name is Ovais. Ovais, please describe yourself and give your background, and everybody should become comfortable with you. In the meanwhile, I'll put my mic on mute because I want to share the live stream on my web page. Go ahead, Ovais.
Assalamu alaikum everyone. My voice is clear? Hello, can you hear me?
Yeah, it's clear.
Hello?
Yes, your voice is clear.
Yeah. So yeah, I'm Mohammad Awais. I have joined BootCamp 2020 in the last year, and I'm just following this stuff and all that. After completing the bootcamp, I just joined Sazia team, and currently we are working with Sazia. And from now on, hopefully, me and Sir Anis and Sazia will teach you what about like how AWS will work. So yeah, that's it.
Sardhya, over to you.
Okay, thank you so much. Thank you so much. Today, what we are going to do is basically look into Dynamodb database. And why, in the last class, basically we covered, if you remember, we covered GraphQL, Anis, and we also covered Postman, how to call a GraphQL query. And Anis did it in the last class. Now today, we are going to learn how to connect to Dynamodb. And before we get started, would you like to give a brief overview of Dynamodb? What are its capabilities? What is Dynamodb? And and then we are going to build a to-do app.
Yeah, actually, what is Dynamodb? The first thing is that we have to understand what is Dynamodb.
Where's your voice is coming a little bit low, at least to me.
Sir, me also.
Is it better now?
Not.
Hello.
Please continue. We will see.
Yeah. So as I am saying that Dynamodb is a database which is provided by AWS. Can I share my screen, sir?
You can share your screen, but we are having some voice problems. All the students are also having voice problems.
Yeah, I'll suggest Awais that could you for a second, can you keep your mic near to your mouth so we can see this is the
Yeah, hello.
So
Better?
now speak please.
Hello. I think there is some problem with my mic. Is it
I think there is some problem with the mic.
Hello.
You can move. Can you move to the built-in mic of your laptop or desktop?
Yeah,
possible.
Can you hear me now?
Yeah. While Awais is setting up his mic, so sir, let me allow to recap something about the CDK and AWS.
Yes, go ahead.
But yeah, so from the beginning, I want to a fast one-liner repeat that from the AWS point of view, we have a CDK, the Cloud Development Stack. Actually, Cloud Development Stack is a set of functions and commands that we use to handle, or I could say provision or manage AWS infrastructure. Under the CDK, there is a cloud formation. It's a level 1 thing. Previously, we were using cloud formation, but later on we moved to the level 2. This is the Cloud Sdk. And this SDK help us a lot because in L1, we have to work on a YAML based notation. But in L2, the CDK, we can program into different languages. The core language is TypeScript.
Hello, 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 hello.
As the core language of CDK,
hello, hello.
Mohammad Awais, I can
Hello.
hear, but your voice is again a bit low. The same thing, there is no update.
Okay, sir, I'm just checking here.
Okay, okay, you keep checking. So when you are okay, so when we are talking about Cloud CDK, there are a lot of things exist. For example, every CDK has some construct. That construct we use to provision or manage different sort of AWS infrastructure, or I could say the environment. For example, the construct exists for managing storage, provisioning virtual machines, and lot of other things. The idea behind is that you just download or work with the TypeScript AWS SDK core, and whenever you need different type of construct, you can use and download. So if you are new to this class, you or you just couldn't remember what had happened last week, so I just to tell you that then the last week we tried to use some Lambda functions using CDK, and in these Lambda function we try to provision a node server that execute a certain function, and without doing anything on the GUI. And because it's a Lambda function, we have to pay only while we are using the Lambda function. This is our the philosophy, that with the use of the CDK, we should able to control everything from the AWS infrastructure. So that's it, sir. Anything else from your side?
Let's test Ovez again. Yes, Ovez.
Is it better now?
A little better.
But try to speak loudly. So at least
change the hand free. Yeah, let me share my screen quickly and show you guys what is AWS and what we are doing today. Okay, can you hear me? Can you see my screen?
Sir, in every class we are learning a new AWS functionality or the service.
Yes.
Is this connect from the previous one?
No, actually there is many services which AWS.
This is a Dynamodb service.
Yeah.
Sir, basically I'm asking, these services are connected from the previous class?
Yes. But first, we will going to cover Dynamodb. You don't have to know the previous class to basically continue with it. Wes, I think your sound problem has not been solved. Would you speak again?
Still you can't hear me?
No, it's very bad. What we'll have to do is basically, we'll start from the next class. You please try to solve this issue.
Yes, sir.
Because the sound is very low. Okay, what I'm going to do is basically, I'm going to share my screen.
Okay, sir. Let me make you co-host, so you will be able to share your screen. Sir, do we need a little bit revise a previous code we have used?
Not right now.
Okay, fine.
Now, what we are doing is doing step number 4 in the CDK repository. And if you take a look at it, what we are going to do is basically first cover the theory. I'm going to cover what Wes would have covered, which is the theory of Amazon DynamoDB. What we are going to do is basically, first of all, let's see what are the options in databases. The first option is DynamoDB. It is the fastest, the best response time. But the problem is, it is a very basic server. Basically, you have a partition key and a primary key. Basically, that's it. You cannot connect tables and rest of the stuff. Therefore, the first option is that you use DynamoDB for simple modeling. For complicated modeling, you have two choices. Either go with Aurora Serverless, which basically is a relational database with unlimited scalability, or go with graph database Neptune. In our class, we are going to focus much more on Neptune because it is a main tool and it is a very powerful tool for artificial intelligence. But that comes later on. So therefore, let me revise. There are three choices. If I was you and I was starting a new project, I will look at for small and simple modeling tasks. DynamoDB is the best. It has the best performance. Number 2, for complicated models, Aurora Serverless, or go with Neptune, which is a graph database. The good thing about Aurora Serverless is that most people who are already in development know relational database. The problem with graph databases is that it is much more immature and it is new, but it is very powerful for AI kind of tasks, and where you have to do a lot of querying, have to find relationships between different tables, basically doing all sort of queries. It is the best. But today we are going to cover DynamoDB. The problem with DynamoDB is that its querying facility is very limited and the modeling capability is also very limited. Yes, Bilal.
Sir, can you little bit explain the graph databases? We mostly know the SQL and PostgreSQL and other databases. Can you little bit explain the graph?
This is going to be covered, Bilal, later on in the classes, in later classes. We are going to cover graph database extensively. But right now, today's task is to focus on DynamoDB. We are going to get started with it, and in later classes, in a later few classes, we are going to cover GraphQL. In AWS case, the name of the GraphQL database is Neptune.
Sir, is it better now? My voice is better now?
Yes, much better, much better.
Okay. So can I sum up something?
Yes.
As you explained that actually the thing is that there is 3 most popular databases which are in the market, which is the relational based database. As you guys listen about the MySQL database, it is a relational database. The second is NoSQL based database, and the third is a graph based database. In the NoSQL based database, the data which we are using right now is the DynamoDB. And in the graph database, which is very popular nowadays, is a Neptune, which, as Sir mentioned, we will cover it in the next classes. So yeah, as a DynamoDB, what it does do. Sir Anis, can I able to share now my screen?
Yes. Let me disconnect my. Stop sharing.
Okay.
Yes, go ahead.
Okay. Now, what is DynamoDB? DynamoDB is a basic database which is provided by AWS. Okay, as you can see in the DynamoDB, we have the tables, items, and attributes. Now, what is table? As you guys already know about it, if you want to create some specific entity for our database, we will create the table first. For example, I want a table for a person. I create a person table. After that, I have an item in it and I have attribute in it. Now, what is item? Item has a limited information in it, and there is a multiple item can be used. And for example, and the attribute is a multiple attribute. For example, person ID, person name, person last name, it will be considered as an item attribute, and collectively they're called and one item. As you can see in this screen, the zoom is fine. Hello.
Yes, sir.
Yeah. So in this, we have a database called people. And in this people database, we have multiple items. And in this item, we have a attribute, which is called person ID, last name, first name, and phone number. As I'm working and practicing on some stuff, I've just created the database, which is in the AWS DynamoDB. As you can see, I have a database created in this. So this is the attribute, the ID, done, and the title. This is called the attribute, and every attribute have the item. So this is all called the item of the one table. For example, there is a one item which is called hello. There's a second item and there is a third item. This is what the DynamoDB is. Now we will see how we can work on the SDK on the lib. So sir, should I just continue how we are going to work and a little code explanation?
We are just going to first look at the little bit theory. Let me just cover a little bit more theory, and then we start looking at the code.
Sure.
I'm going to share my screen. Therefore, the first thing you have to do is, this is a UI-based interface, which we are going to first discuss. And later on, Anis and Uwais are going to show you how to do it in using Cloud Development Kit. Look at this. First of all, you search for DynamoDB service. Then you create a table. In that table, the first thing is, you have to understand there are two keys. One is called the partition key. Then the other one is called the sort key. Now, what is a partition key? This is a value that DynamoDB uses for internal hash function to determine the physical storage location of the item to be stored. And what is the sort key? This is used to sort items with matching partition keys. You can concatenate multiple keys together to create a unique key. So therefore, there are two options. So therefore, in a normal database, you have to understand that there is always a primary key and then there are secondary keys. Here is a little bit more complicated. The complication stems from that if you want to create a simple primary key, what you have to do is just define the partition key. And if you want to create a composite key where you will also have to define the partition key and the sort key, together they should be unique. Let me repeat it again. You have two options. Number one, you define a simple primary key, in which case you just define the partition key. For example, you will just say if there is a table which is recording the reviews on a product, you just, and there is only one review. So therefore, what you will do is you will have one partition key, which will be the product ID. But if it is a review, then there can be many reviews for a particular product. Therefore, what do? You define a composite key in which you have a partition key or product ID and a sort key, which is the date. So there are two keys which are required to basically search for it. Now the problem is, even this sort key, in this example, on a particular date, you can have more than one comment, one review. So then what do? How to make it, if you have a composite key, how to make it unique? So therefore, what you do is, in the sort key, you merge the review ID as well as the date. So therefore, sort key will be a composite of two keys, concatenation of two keys. So therefore, the uniqueness will come from the partition key, which is the product key, product ID, and the sort key, which is the review date plus the review ID. You concoct in sort key. Now, your understanding, it's getting not as pretty as we will see in relational databases and graph databases. So therefore, I suggest where you know the query beforehand and you have a typical kind of query. For example, you just want to search users by their ID, their user ID. Dynamodb is very good because it will give you data very fast. It is already scaled, millisecond performance, and you are you can show your customers anything you want in a few milliseconds. Now let me revise again. Take this example. We want to stay. We have a product which is, say, customer ID, review ID, product ID, review date, and review body. We are trying to record reviews. Now, these are the data we want to save. Now, what to make partition ID and what to make of sort ID. Therefore, what will happen is that in this case, you will make product ID the partition key. And what is a partition key? Where, think of it as a machine, conceptually. There's some machine somewhere, and this product ID will match that machine. Every product ID will be stored in a different machine. Now, let's assume if somebody does not use product ID, but says for everything, I'll put a 1 in the partition ID. The problem with that is all the data will be stored in a single machine. So virtual machine somewhere, and it will really slow down. It is called hotkeys. Don't do that. What you have to do is think of partition key as a concept where you are going to divide your database on the basis of that key. Divide your table on the basis of that key. So therefore, always select a partition ID, which, for example, or always select a partition ID, for example, which, let's say, you think there are 1,000 rows. So therefore, the partition ID will be such that there are not more than 20, 30 rows per partition ID, or maybe 100 rows per partition ID. Now, in order to get unique, what we are going to do is, for sort key, we are going to use the review date plus the review ID. Now come in a single key, which is called the sort key. Now the primary key becomes the partition key plus the sort key, which includes the review date and the review ID. And the review date and the review ID. And review ID, the sort key, and product ID is the partition key. Now, you can have other indexes as well. You can create additional indexes, which will cost you money. Therefore, if you want to have additional indexes, you will have to create additional indexes, which will cost you memory and CPU time. But the main table of Dynamodb can only have a partition key and a sort key. This is how you search for it. But if you want to create search on the, for example, basis of customer ID in this example, because it's not included in the, if you want to sort on the basis of customer ID, what you will have to do is basically create another index. Everybody got it? Any questions?
Sir, let me ask a few questions just to clarify. So the customer ID would not be selected as the partition key or the primary key because it would be too unique for every customer, right?
Yes.
Because then every customer will have a different partition, and it will be a very small partition, right?
Yeah, exactly. If I selected customer ID, I'm just repeating what you said. If I selected customer ID as a partition key, what will happen is there are too many, and it will have only a few rows, 2-3 rows. Just go ahead, Samar.
Okay, sir, it's clear to me. Thank you so much.
And what we did was product ID, because each product will have many. And then for sort key, we concocted the review ID and the review date. That's why I don't like NoSQL databases very much. MongoDB, I've used MongoDB, and MongoDB has improved a lot recently, but I don't like it because usually when I'm modeling something, it is quite complicated. And in order to think about the databases, you have to change your model. And I don't like the basically jumping through loops to query and have all the queries beforehand and all the rest of the stuff. It's too much. As I mentioned, for example, somebody wants to now if somebody wants to question customer ID, I have to create another index and so on. It's too much work and too complicated. Wes, are you there?
Can you repeat
Yes, sir.
again,
Yes, sir.
if you don't mind?
Yes. Who is that, please?
Can you repeat all of the stuff that you taught me?
Now, what I was saying is, look at this thing. I want to save this in the Dynamodb table, which is a customer ID, a review ID, a product ID, a review date, and a review body. It's a review of some product, and I'm storing it in the database. As I already mentioned, that you have two keys, the partition key and the sort key. Now the question is how to basically, which is going to be the partition key and which is going to be the sort key. And it has combined, either you just use the partition key, and combined there should be unique. Therefore, our solution is that we use product ID as a partition key and take two things, which is the review ID and the review date, join them together and create a sort key. This will make it unique. We are not using the customer ID because as a key, because as a partition key, because it will make the bucket too small, the partition too small. So therefore, the product ID is the best way. So therefore, that is thing.
Sir, basically,
If you can ask a little bit specific regarding your concern. So we will be able to provide you more detail rather than repeating everything again and again.
Sir,
Yes,
for example-
what I understand that basically a customer ID is the whole name of the table, and the attributes
No,
are
no, customer
reviewed.
ID is not the whole name of the table. It is one of the fields. What is the name
One
of
of
the
the-
table doesn't matter that much.
Let Bilal, I guess let understand the concept. Actually, Sarji always says if you have a good concept, you can think or you can understand things very well. The issue is that we have a review. I hope you understand that what review is. Review is the product reviews that user provide. So a customer after buying a product provide a review. So the concept is we want to share a review in our database, and because we are going to share a review from the customer, there will be a customer ID. It means the customer who shared his review, and a product ID, and the review date and certain things.
2 minutes and 18 seconds. Get ready.
Excuse me, Bashir Aziz, could you please repeat? I could not hear you well. Hello.
I think there was some, he was talking to somebody.
Okay, fine. So so now there is a review and there is a certain things. We have a certain information. Don't confuse it with the column. We have a set of information. For example, a review contain a product ID, a customer ID, a review date, and the text message. Now we want to store. We have to understand that which key we want to use to sort our data to make it unique. For example, if we want to store our data in our database, we have to know how could we access that back. For such purpose, we need some primary key so we can access our back, and a key that can be used to store data into different area, so we could easily retrieve our data in a very short time. So at this point, we are using a primary key that is a composite key, because there is no primary key exists. There are multiple products exist. There are multiple customer exist. So we are making a key which is combining two keys. One is review date and one is the customer ID to make it a unique. So now tell me where you are stuck at this point.
I'm just going to review something. The table name is product reviews. So therefore, this is not the tables. These are the columns. Let's move forward. We are moving forward. Uwais?
Yes, sir.
You were going to cover the theory of the code.
Yes, sir. Sure. So can you please stop your screen so I can share my screen?
Yes.
Everyone can see my screen.
Yes, you will have to speak a little louder.
Is it better now?
Yes, yes.
Okay. So now what we have to do, as you guys study on the previous classes, how the Lambda function.
Sorry, Aves, your voice is still a little low. I suggest you, sorry to say, but I suggest you to do not speak. You have to shout so we can understand well.
So, sir, is it better now?
Yes, it is better.
Okay. I'm just following the instruction of Sarani. So yeah, as you guys just study about the code, how the Lambda is created and how everything is work on the CDK, we will repeat it fast and just to see how the things is happening on the backend side for the creation of the AWS. So first for you, what you have to do is always import the CDK from the AWS CDK core. After that, you have to import the Appsync. We will see what is Appsync will do. And after that, we have to import the Dynamodb, so we can connect and create our table for the Dynamodb. And we will also create a Lambda function. You have to also import it. After that, in the class of the CDK constructor, what you have to do is you have to create a constructor for the Appsync API. So what we want to do is that we want to do is we will tell you Appsync that this is our database and this is our GraphQL schema, which is located on the GraphQL folder under the schema file. So what we are telling is that go to the GraphQL folder and in the schema file, pick the schema file there. So our Appsync will know about it, how to connect our database with the schema file. After that, what we are going to do is to create a Lambda function. In the Lambda function, we are telling that what is the main handler our Lambda function will pick and where it is on the function folder. After that, what we are going to do is we are telling we will create our Lambda variable in this. What is this? This is the API which we have just created here. After we will connect it with the add Lambda source. We have to define and we have to tell our Lambda what source our API will require. So for that, we add the add Lambda source here, we name it, and we tell the reference of the Lambda we have just created. After that, what we're going to do is we will create resolver. In the resolver, we will define what our resolver will do, what action we are performing for that database. The query, we will use the query. If you want to get the data from the database, we will use the query. And if you want to add something, delete something, or update something, we will use the mutation for it. And under that, we will define the name of the query, what we want to do. And like that, we add the add to do name, delete to do name, and we create our all resolver here. The resolver is created, the Lambda function is created. Now we will define our table.
Wait a minute, Aves. Just I want to ask everyone that are you getting what Aves is stating here? He started from providing you information regarding how would you copy from the GraphQL.
It's going fine. It's quite clear.
Sir, it's clear, sir.
I couldn't hear your voice.
It's clear, sir.
Okay.
Clear.
Thank you. Can you please mute your mic? Yeah. Okay. So what we have done last, we have created our resolver and define our sources, what our action and what our Lambda will do. After that, we will create a table. In the table variable, what we are going to do is creating a new object. And what is this? We are importing the Dynamodb from here. And we are telling that there is a Dynamodb and there is a table. And just create the table name here. After that, we are giving the partition key here, which is ID. And the type of the partition key is string. Okay. After we have defined our table.
Sorry, Aves, disturbing you again. Can you please enlarge the screen size or at least font size?
Sir, is it better now? Is it better now, sir? Hello.
Yes, sir.
Okay. So after we create our table, what we want to do is give access to our table. So our table can access our Lambda function, which we have just defined here. Okay. After we add the environment variable here and give the environment variable name and the table name, we defined our table name in the environmental variable here. And after that, we are printing our GraphQL APIs and the keys of our GraphQL APIs. So should I move forward to the functions, what we will create on the Lambda function, or should you?
Let me share my screen and go over it again.
Okay.
Because it takes time for a new person to understand something.
Yes, please, sir.
Could you unshare your screen, please?
Yes, I do.
Now you guys can show me. The first thing is, we want to create a to-do app. That's our objective. Now, what is the first thing you will do? The first thing you will do is create a schema for the GraphQL queries. And the mutation. Somebody is basically please mute your mic. So therefore, this is the first thing you have to understand. The GraphQL queries, this is a GraphQL query. What does it do? It says get to do's and it returns an array of what to do. Therefore, the first thing you have is a to do type. The to do type, and in that to do type, you have an ID, a string, and a boolean. What does boolean signify? Whether the to do thing is done or not done. So therefore, my first query is get me all the to do's. So therefore, it returns all the to do's. And as you remember, we talked about in the last class, the query is the root. From the root, you have to basically search. Then you have three kinds of mutations. In the last class, we did not cover this. What is a mutation? When you want to update the database. And basically, you are telling GraphQL that this thing will be this update the database. So therefore, the first thing is add to do. Then the second thing is update to do. And the third one is delete to do. In the delete, you just give the ID and it deletes. In the update and add, you basically pass the whole item. Everybody understand this schema? That's what we are going to do.
Okay, sir.
Yes, sir. It means that there are one thing. What is the query? Query is a default function that will return the list of to do. While mutation function actually is using to change, update, or insert the data. While the top one, I couldn't see, the screen is a little down level. So I guess the schema is quite clear. If anyone have a question, please raise your concern.
If I was in your place, I would have asked, why did I have a to do and a to do input? Because this is going in and this is coming out. So therefore, we used a different type. For input, you use a different type. Everybody understands this?
Yeah.
Can we move forward?
Yes.
Yes, sir.
Abhi?
Yes, sir.
Okay, let's move forward. Now, this is a, what do you call? This is a schema. Now, the second thing is, now I understand what the schema is. Now, what I have to do is basically write a CDK construct which creates all the things. So let's go to the lib folder in which we have defined the stack. Let's understand the flow. The user comes in and queries the GraphQL, which is Appsync. The Appsync is connected. You query your Appsync. Appsync is connected to a Lambda function, and Lambda function connects to a Dynamodb and gets the data out of that. Now, first thing we have to do is look at this thing. We have to create a Appsync API. In order to do that, we pass this, which is the context, then the name, and what we say is this API name is, this is, what's the difference between this name and this name? This name uniquely identifies the construct. in the construct tree. And this is the actual name of the API. Then you say, load, remember we just covered the schema. You say, load the schema from here. And then you say that authorization will be through API key and app key config expires in 365 days. So therefore, we have already covered this in the last class. You have defined the API in this construct. Now,
Sir,
yes, Raza.
sir, what is API key and what is used for? What it is used for?
The thing is, it will be used for authentication. We don't want anybody to connect to your database. So therefore, your APIs. Therefore, what you are saying is that this API key you must include it in your header, which they will give. So to call the API.
Okay, sir.
Now let's move forward. Now the second thing is we have the Appsync. The Appsync is now has to be connected to the Lambda function. But before that, you have to create the Lambda function. How to do that? We have done that already also in the last class. We say Lambda dot function, and we say it's the Node.js 12. It is saying main dot handler. This is the name of the handler. Now let's look at the Lambda function. Lambda function will be where in the function directory. Look at this. This is the function directory. Go to the function directory, and which is the handler? It is main dot handler. So this is the main thing. Basically, what you are saying is now this Lambda function will be called. We will go Lambda function in detail later. So this Lambda function will be called. This Lambda function, when called, whenever there is a query, this Lambda function will be called. Now we want to say that in case of the first thing we have to define is the to-do item. What we have done is created a common to-do item, which is in this, which is a type to do with the ID, title, and done. This is the type, and we have exported it. Now in the main, what we are going to do is import it. And we have already done it. Look at this. We have imported it. Now what we are saying is, if we want to add to do, what we are doing is we calling a asynchronous method, which we'll cover later. Let's go to and check add to do. This is another separate file. In the add to do, we are saying we have imported AWS SDK. Look at this, AWS SDK. And in that SDK, we have a AWS Dynamodb document client. We have imported both. And what we are saying is, using this library, we have called the put method and passed in the parameters. And it is an asynchronous function, and therefore we are calling the promise. So therefore, what is the asynchronous function? Let's call, which is defined by the AWS SDK. And it returns a to-do item, and basically we have, by using put, we have added the item to the database. Now, the question is, where do we get the table name? We have to check the CDK, how to do that. The table name is coming from the process environment variables, which is set by the CDK. You'll see how they do it. Now, let me repeat it again. The main Lambda function is this main. In this main, we have imported the to-do item and we have imported the 4 methods, get to-dos and update to-do and so on here. And whatever parameter we get through the resolvers, we basically call the separate methods so that all the code is not inside the main Lambda function. You can write all the code in the Lambda function also, but we have created different classes with different functions to do this. Now let's go back to the lib. Which is, we have already created the API, already discussed it. Now we are creating a Lambda function and we are saying main.handler. Where should it get it from? Functions. Memory size is 1024. You can increase the memory, but it will cost you. So therefore, you have two things. You have the API and the Lambda functions, but they are not connected. Therefore, you are saying API and Lambda source, and you're connecting this to the to-do Lambda, this thing, which is to-do Lambda. Therefore, you have connected the both of them. Now, the Appsync will call the Lambda function. Now, you want to define the resolvers. The resolver in GraphQL, you're saying one is a query. Look at the schema. The other one is a mutation. Let's go back and look at the schema. Add to do, update to do, query is get to do. So let's see how do we define the what do you call resolvers. This is a query and just give it the name of the query, get to do. This is a mutation, add to do. And where you get add to do? Look, go back to the schema and you say add to do. Let's go back. Same way you do it, mutation up to update to do, and so on. Now what we are doing is, we have not created the table yet. Look at this. We are saying, create a table and the partition key is ID and the attribute type is string. But I told you that you also have to define the sort key, but there is no sort key. Why there is no sort key? Because we are using primary key as only the partition key. We are not defining the sort key. As I mentioned, there are two types of primary keys. A simple primary key where you just define the partition key, and a complex primary key in which you define the primary key as well as the sort key. Here we are not defining the sort key. Now we have created the table here. And then what we do is, we grant full access to the table. To the Lambda function. We grant full access to the Lambda function to call the table. Otherwise, the table will not be able to call the Lambda function because it is because of security. And then what you say that in the environment of the Lambda function, please add the to-do table and the name of the table. The name of the table is created by the AWS. So how do we go back to main? And how do you get the table name? If you go to add to do, you get it from process.environment or the name of the table. In the environment variable, we have basically attached the name of the table. See here. Therefore, in the environment, and we are getting it out in the Lambda function. Now look at this thing. First, we are outputting GraphQL API URL and printing it out. Then GraphQL API key, you are printing it out. And the stack region, of course, if you want to. Now this is the full implementation of the to-do app in GraphQL using GraphQL as well as Lambda functions. Questions?
Sir, what is stack region?
What we are going to do is basically, if you don't understand, what we are going to do is do a lot of coding here, write it from scratch so that you understand everything.
Yes, sir. Sir, can I repeat it as I learned something, certain things?
Yes, go ahead.
Sir. So, if you want to review these codes, I would share the link also. So, the first thing you need to, we were going backward. The sir provide us from the level 1 to level last. But I'll go.
Anish, what I'm doing is stop sharing my screen so that you can share your screen and then.
Yeah, okay, fine. Classes and objects CD. Okay. I hope you can you are able to share this screen. VR and I step.
Sir, please zoom out a little bit.
Is it more large than a bit?
Yeah. Just zoom out.
Wait a minute. Let me set. Let me reach to the level 4. Okay. Okay. Is this good enough?
Yes.
Yes. Okay. So first thing, I'm first take you forward from forward to backward, and this is the package.json. The package.json provides us what we are going to do. For example, no, it's not. It's a yeah. Okay, it's a step 4, and it has package.json. Okay. So if you want to review certain codes, the main thing you have to learn that where it will start, and then it will start from the bin, step this one and this file. After reading this code line, we can understand that the next attack would be on the bin folder. In the bin folder, there is certain has been written, which says that we have to import source map support register and imports everything from the CDK from this folder, and as well as we need to move here. We need to certain things which is called step 04 Appsync Dynamodb stack. We will download from there. What we will download that? We will download this thing. As I click that, I could know that I imported an object from this code, and these codes become going to be used in such a way. This is the app, I mean the parent class, we have already understand, and this is a ID. I can go indirectly or directly from this code. If I'll go to type definition directly from here, so or I can go from direct. So you can see that there is a class which is the step 04 Appsync Dynamodb that expand from the CDK stack. We understand that stack means all AWS resources are named in the CDK as a stack. For example, Lambda is a stack, DynamoDB is a stack, and Appsync is a stack, and S3 is also a stack. So what we're going to do, we want to stack, extend this stack, and for the extending a stack, we need a scope, which is this one, and ID, and certain properties. This is a hard-coded thing we need, because without using this construct, we won't able to extend this code or extend this class. Again, there is a constructor here, which is called API, and which is actually GraphQL API. We have already learned about GraphQL API in the last class, so you can watch the video of the last class. Again, there is a parent, there is an ID, and again, the start of the properties. The first property says that this is the name of that API, and there is a schema which exists in the GraphQL. If you want, I guess it should be available if I'll go to the definition, but it's not going on. So I could see, I could guess easily that it would be available in the GraphQL library. So what this schema read, the schema available in a file, and it would be read into that schema. After then, there is authorization, which provide a secure key. That secure key is required because you are communicating one service to another service over the HTTPS. So here your secure key would be used as a public IP. Now there is a other construct exists which says this is the to do lambda. It means this is again we have discussed already in the last video, so we should be remember that what we will do, this function or this construct will instance a virtual machine that would have Node.js, and the main code would be the main handler, and the code would be run from the functions. So it means I can easily understand that I need to go inside the function folder, and in the function folder you can see there is a main TS exists. So it means that all further code would be exist here. It also means that this to do lambda function, the lambda would be start, and the first code would be from this thing, and it will start running that code. The code will start running. It will again import certain codes from the other functions. The first thing is a type. We were stating the type of Appsync, which is the information is a string and argument, this type of things. And again, this is the main part, which actually define our routing of our system. It says that if the GraphQL call has a field name to do, add to do, we will run add to do. If it would have get to do's, it will run to do's, get to do's. If we would have delete, whatever function available in the field name, we will run the required function. For example, get to do's, I guess directly go to the definition. Yeah, I guess. So in the get to do's, I could require certain code related to the data, and these data would be extracted from our DynamoDB storage and get back to the main file. So this is where we were. I'll go back from here. The other thing that says that the Lambda data structure, which provide the information regarding how the Lambda would be processed. For example, if the query, the field name would be get to do as, if there is a field name would be mutation, so this will and that would be run. So what I have learned, I have mentioned here you already. If you have any question, so you can ask. Otherwise, I'll move screen back to Sarzia.
What we have to do is, Anish, we'll start coding. What we are going to do is let's open a new directory.
Okay, fine.
Let's start coding.
Yeah. Actually, I am creating a directory which is not visible in this server. So yeah, this is new folder. This is a step 04. Okay, sorry, it's a step 03. Sir, I am here in the step 04. So I guess I have to initiate a new, I would say,
You have already created a new, this is a new directory?
yeah, of course. So
Okay.
do I said to say,
Now let's, the first thing is, let's make sure that you have the, I want to train all the students. This is a limitation of the latest, the 1.0 CDK. Whenever you start working, always update your CDK. So therefore, let's say npm install. Anish, I think we'll have to create another command line. This command line is too large. The directory is too large. We don't get to see anything.
Okay, okay. I guess actually we are very much deep in the folder. So let me create a directory in a starting area. Okay.
Yes.
As Sir Anis is creating the directory, I want to mention that for using the CDK, you have to configure and create a user account in your Amazon account. So you can configure it on your command line, and then you can use it and deploy the CDK functionality on that.
Sir, so we need to update the CDK, I guess.
Yes. What do you say? Say npm I, which is install AWS-CDK -G.
Actually, we need to initialize, I guess. I put it away. Tell me the code for init dash init, node dash init, or what?
So what do you want to initialize?
Yeah.
AWS. We are installing AWS CDK globally. Doesn't have to do that anything.
Yeah, it will globally install in your PC.
It's asking actually.
Sir, they remove the minus from before I.
Sorry. Okay, done.
Now let's see, check the version. The CDK.
It's a 1.2.2.
Yeah, this is the latest. Now what will happen is, whenever you are initializing and doing rest of the stuff, Now what we want to do is basically we want to initialize the directory you have just created. And how do you do that? And you want to tell the CDK that basically create all the scaffolding.
So
Now what
I
I'm
guess
going to do is write the command. I'm going to write the command in the chat window. Basically, you are saying CDK init app -- language space TypeScript.
So what it will do, it will create a demo directory for us, so we can easily create our architecture on that.
Exactly. What he is doing is setting up the project so that you can start writing code.
okay, sir. So from where we will start, bin or lib? Or I guess we need to create a folder which is a GraphQL.
Yes. First step
And we
is,
will also create.
remember the first step is that we are going to create the schema.
Yeah.
And then create a file GraphQL schema.ql or something. Schema.gql.
Sir, wait a minute. Schema.gql. This is good enough. Do I need to copy paste the schema here, or I have to write again?
No, it will take too much time. We don't have enough time. Just copy paste the schema.
Okay, wait a minute. I need to open that directory once again.
Let me give you the code that so that everybody also understands it from the. Now this is the to-do schema. I'm going to. This is the to-do schema.
Okay, fine, sir. I'll chat. So we have specified that what type it be to do. Input is a to do input and query. Sir, what is the difference between the two type to do and type query? I guess query is a reserve type of thing here.
Wes, would you like to explain it?
Actually, so what we are doing is that in the query type, we are defining that whatever the query get to do's want is in the to do type. So when the user call the get to do, it will know that from where I want the data, like ID, title, done. So it will get that from the to do. So we do not have to write again and again.
Basically, it is saying to do type. So therefore, we have defined a type of to do and an input of to do input, just to differentiate it. And whenever the query basically returns all the to do's, and if you go down, Anish,
yes, sir.
The mutations are where you are updating the databases. And mutations are basically three: add to do, update to do, and delete to do, of course. Therefore, we have defined the schema. Now let's go to the lib section.
something is already created here for us. So we have to code after that.
Yes, exactly. Now go to the lib, and here we have already defined a stack. But the first thing we have to do is define an API. Therefore, what do? In order to define an API, you create a Appsync stack. But before you do that, you have to import it, install it. Remember, Anish, you have to do is go to the command line.
I have to, wait a minute, I have a code for this, which says that I have to install the Appsync. I do not need to install AWS CDK, because the AWS CDK is a part of core CDK, so I does not need to install. But for other things we have need to use, I need to install. Okay.
Therefore, npm
I'm not using G here. It means that this Appsync would be specific to this folder and this project. Am I right?
Yes,
sir?
exactly.
Okay. I guess, is this done, sir?
Now the Appsync is installed. You have to basically import it
Yes, sir.
on the top.
Wait a minute, sir. Okay. Sir, what thing we are going to
Just copy it here. You can name it anything. Just have to copy the first one.
Sir, copy the first line and just mention this like that on the first line and just change the text.
So when I am going to
Just yeah, Appsync.
Is this right now?
Yeah, so Appsync spelling is wrong.
Here?
No. Yeah, after as. Yeah.
I couldn't understand what does it mean. I have to write Appsync. You want to say me this right, like, okay? Is everything correct here?
Yes, exactly.
Yes, sir.
Okay.
Now, the first construct, we have to build the first construct. I've already sent you on the chat.
Sir, I'm checking.
Sir, Anish, you can also open the GitHub repository, so it can be easier to look forward to the code and copy from
Actually,
there.
you are right. The GitHub repository already downloaded, but I want to copy from the chat window to prove that everyone could code after copying from the chat window. Huh?
Yeah, it
So,
will be easy for everyone.
yeah. So that's why things getting a bit complicated, but let's see. I want to also, for example, I'm manually formatting certain things. Okay.
Right click on the VS Code and it will have an option of auto formatting, so it will format for you.
format document.
Yes, sir.
So thank you so much. So gentlemen, now you can easily understand that what I am going to do. I copy data from what Sarzia shared me, and I have formatted the data. So this
Yeah,
construct
as we
actually,
explained before, we are
yeah,
defining our API route here. So we will defining here that where is our GraphQL schema is. So our Appsync will communicate with our GraphQL schema.
Now we have created a API,
Yes.
which is the GraphQL API. And Uwais, could you just explain the construct again so that everybody understands?
Actually, what we are doing is we are defining our new Appsync GraphQL API. In this API, we are telling that in the brackets, we are defining that this and this is the API. And after that, we are defining the name of the API, which is CDK to do Appsync API. After that, we are defining the schema. In the schema, we are telling that from where you have to get the schema file. So for that, we are giving the appsync.schema.form asset. And in the form asset brackets, you can see that we are defining the GraphQL folder. And in the GraphQL folder, we are saying that there is a schema file, get the schema file there. And after that, we are authorization for our API. So it will know that what we have to do. So for that, what we do is default authorization. In the default authorization, what we're gonna do is authorize the Appsync authorization with the API key. After that, we define that how much long it will, the duration will be the 365 days. And on the last, we are saying that there is a x-ray enable true. So it will create our API, Appsync API GraphQL.
Now, understand this. We have already referred to the schema. The APIs are defined. It is, we are telling it that use the API key. Now the second thing is, before we have to define the Lambda function, which is going to connect to the GraphQL API. But in order to do that, we will have to first install it. One is npm I Lambda.
So you can check on the
AWS - Lambda. Now, we have to import it.
The imports in the chat.
Exactly. Now we are going to basically define the Lambda. I'm going to copy code to your chat window. Let's define the Lambda. We have already defined the APIs. The second step is define the Lambda. Now we have the both things. We have defined the APIs and we have defined the Lambda. Uwais, can you explain the Lambda construct?
Yes, sir. As what we are doing here, is defining our
You have to
lambda.
speak. You have to speak a little louder, please.
Okay, sir. So we are defining our lambda. In the lambda, we are just creating the new object, and in which we are creating the lambda dot function. And in the function, we are telling the lambda name like this. And after that, we are defining the lambda name. And under the lambda, we are defining that what runtime the lambda will be run. So it will be the node, and the version will be 12. And after that, we are defining the where is our lambda located. So the handler would be the man dot handler, which we will give in the function folder after that. And the code lambda code is coming from the function folder, as I just mentioned, and the memory side, that what the memory side will the lambda will consist, and it will be the 1024.
Exactly.
What is the memory size?
Actually, every lambda has a memory size on the AWS, so it can monitor and charge you accordingly. So if you give the memory size above that, it will charge you. So on the free tier basis, you should follow the instruction as just defined here.
What is this?
But,
What is the unit?
but in the previous classes, we know that the lambda function is auto scaling. We just fire the lambda function, all of the stuff handled by the AWS. What is the limitation, and I can't understand what is this now?
So do you want to mention this, or I just continue?
Please go ahead.
Yeah. Actually, the memory size, if we are defining the memory size, it is the size of the lambda function itself. The scalability remains the same, but we have to define that there is a specific limit of the size limit. So in the free tier, the limit doesn't goes beyond that. So you can just use it. But for the big application, we need the lambda function for the scalability. So there is no issue for the scalability. So we will define the memory size according to that. For our simple application, we will defining the 1024 for our code demonstration.
One more thing from the my side. It's just start. We can add further information like scalability and all a lot of things using the properties. So you can go and get some documentation. So I guess you would be able to see how to control the scalability. Currently, we are limiting our scalability actually.
Yes, sir. Yes.
Now let's create in the root project directory. Anish, create a directory called functions so that we can put the lambda there.
Yes, sir. So previously, in the previous class, we just used a lib directory and the bin directory. But now we are also adding a function.
Not in the.
directory.
I think you are misplacing it. It is not. It shouldn't be in the lib directory. It should be in the root directory.
Yeah.
Yes, sir, in your root directory.
As usual.
So what will be happen if the memory size of the lambda function will be greater than the size that you given?
What will happen is that it will crash out of memory. There is a default memory, and depending on the size and how much you are processing, you define the memory. But if you don't define it, it will give a default memory.
But sir, you said that lambda function is auto scaling and having all the construct behind the scene.
Here you are not considering the auto scaling situation. Auto scaling options is available, but we cannot allow auto scaling without any conditions. So there is some limits exist, and we are specifying that limit. If you could remember, in our last class, did we specify auto scaling?
No, we did not.
We did not. We did not limit our code to use a certain memory. So this time, while I guess the ways and other people were coding, they introduced a limit function. It means that the memory would not be used beyond this limit. So even in the auto scaling, you can limit something. For example, if 5,000 people certainly attack on your Lambda function, it might be explode the AWS and you could charge me thousands of dollars. So you have to understand that where the limit is. So every time whatever we are learning, actually we are also learning certain things. So if you think that Lambda function need to be scale up, you can tune its required parameters or properties as per your need.
Okay, let's move ahead. In the function directory, let's create a main.ts. This will be the main file which has been specified in the Lambda function, which will contain the Lambda function. Everything else will be called inside the Lambda function, from the Lambda function.
So guys, as you can see that we are working on our coding bit by bit, and yeah, and you can see that there's a certain error exists which says that is not exist.
Because we are going to build it. Now create another directory, another file called todo.ts. Here we are going to define the exact object, the todo object.
Add to do or get to do. Where should we start?
Only
to do. Let's first define the type. Let's define the type, which is todo.ts.
Okay.
I've sent you the code on chat.
Okay, sir. Okay, sir. What is our
Now, Oves, could you explain this code todo.ts?
Actually, what we are doing is, if we see our schema, as in our schema we define our type, and in that type we define our variable, and in those parameters we define our type to the ID, title, and done. So as it is, we are doing here now, and after that we will import it to our main Lambda function. So it will call accordingly to our main function, like add to and delete to do whatever you want to do.
Okay.
Now,
actually, what is the relationship between this to do and the schema to do? There's a to do in the
so we have to follow the schema structure. What we structure on our schema, we have to, as it is, do it on the AWS, because when it compares both of them, it will not match and it will give you the error.
Okay, so these to do actually are explained in that file.
Yes, sir.
Yeah. So actually, in the GraphQL, we have using a word to do, which is not explained here.
Word types.
Yeah. So in this, we define a type to do, which is an object which has contained ID, title, and done. These three fields exist, and we are exporting as to do. So now in that schema, whenever to do would be automatically get information from here.
Yes, sir. Yes.
Okay. So
after
now
that, we will
this
import
function
it
we are
on the
going to
main.
again, which is our next function.
Add to do.
Okay.
What we are going to do is, first understand, we are going to, from that main, go back to the main.ts.
Yes, sir, I am going there.
In the main.ts, if you go to the handler, look at this. It is calling a method add to do. Yes. Now let's write that down in a separate file.
Okay. Add to do. Sir, why still I have while I have created this file, the todo.ts, why still I am getting this error?
You'll see because you have not compiled it yet.
Okay. Okay. Here we are using a constructor AWS, a constructor doc client, and Aves will describe us further.
Yes. Oves, please explain
Yes, sir.
add to file.
Actually, what we are doing in add to do, if you look at the first line, we are importing the AWS SDK. And after that, on the second line, we are defining the doc client, which will give the permission to the AWS to save our file to the Dynamodb. After that, we are importing our to-do file, which we have just created for the typing. And then after we create the async function, in the async function, we are defining that there is a to-do and there is a type of to-do. If you, sir, go back to the GraphQL.
Wait a minute.
Schema. In the parameter, you can see there is a add to do. There's a parameter of to do, and where we are defining the to do input. Same like that in our add to do ts file. In the brackets of the function, we are defining our parameter. So can you please go to the add to do ts file again? Yes. So after we define our to do in the parameters and they define over there the types, we are defining that the what parameter you have to pick from this. So in the parameter section, we are defining the table name, which we have just defined in the previous file. And after that, what is the item? The item should be the to do. And we are giving that if you have to try and giving the, in the try function, we are giving the doc client dot put the params which we have defined in the params, and there is a promise. After that, the the promise is completed, return our to do item, otherwise give us the error in the console log or the return the null. This is what the function is doing to put our item in the database.
Now, Oves, we have to install AWS SDK or already?
No, sir. Yes, you have to first install the SDK first, because you are imported on the first line. If the SDK is not installed, the other things will not be work.
Yes, exactly.
And after installing, you have to give the types because we are using the TypeScript. And if you do not give the types, it will again give you the error.
Okay, let's see when we compile.
So why we are using require here rather than import? Any good sense?
Actually, this require was used in Node.js previously. Therefore, this AWS SDK is basically a backward compatibility. For backward compatibility, we are using it. It used to be done in Node.js, was not supporting the latest JavaScript imports.
Okay.
Let's move ahead. Any questions? Now we have done add to do. Let's say, let's do get to do's. We are going to go over it because it's taking a lot of time in a fast manner. Anish,
Yes, sir.
I just copied you.
The last one, I guess I have already copied.
It is get to do's.
Get to do. Okay. This is the get to do's, and the third one is, sir.
Update to do, which I am going to copy here.
Sir, after add to do's, you shared me get to do's.
Yes. Houston, we have a problem.
Okay, sir, but get to do's already. I guess you need to send me update to do's code.
That's what I said. When Apollo 11 was a problem, when Apollo 11 had a problem, basically it called Houston. The astronaut said,
Okay.
Houston, we have a problem.
Then
Then the rocket was about to explode. The problem is that the chat window is not allowing me to copy and paste update to do's because it's too long. You will have to copy it directly from the.
okay, sir. We are function.
Whenever there is a problem, I always say, Houston, we have a problem.
Sir, you can upload the file, I guess, but what I'll do, I'll copy the all codes first, and then I'll let the file uploaded from to the chat window.
You can't upload it because the size is too big.
Even I can't send as a file.
You can send it as a file, I think.
Yeah. Let me try. BootCamp try one server less 4 functions and update to this. Let's see.
Let me copy it.
Sir, I have already copied it. I just want to know that if somebody able to download it.
It's okay, sir. You can just continue.
Okay. The last one is, I guess, delete to do.
Yeah, you can just continue from that.
Okay, that's all. I guess we have created all functions. And the main function. So do I need to compile? So these red lines.
Just to see if there is no errors, why don't you compile?
Yes, sir. So writing TSC would be good enough.
That is also good enough.
Found one error. Update to do.
I think there's some name change, name problem.
Update to do. Update.
The file name must be different.
I guess I didn't copy the update one, or I guess it couldn't save. Something happened. New file. Update. To do. So where I have code. Update to. This is delete. This is update. This is get. Actually, sir, I guess that I did not created the update to do. Update to do's. Okay. The to do should be. I added extra S in this. So now, type once again. I couldn't get any error yet. And
Therefore, it is everything is okay.
Except this one.
Sir, try to close your VS Code and open it again. Sometimes it's because of VS Code.
Okay.
Just close all the VS Code and open it again. The whole ID.
Where I am dot.
So what I like to do is just import all the functions again. So
your voice is not clear.
So using this Jugadu style, at least these codes error has been eliminated. So, okay, fine. So what has been left away?
So everything is done now. What we have to do is
we have created bin. Okay.
Yeah.
In the bin, this is only one thing written here.
No, sir. It should be the second file. Yeah.
Okay.
Yeah.
This file. Okay.
Everything is defined here already.
And let's go back to the lib. Let's go back to the stack in the lib.
Okay. This is the stack. Okay.
Not this file. Step4.ts.
Sorry.
Now we have defined the API. We have also defined the Lambda function. But what we have to do is basically connect the two. How do you connect that two?
This Lambda function with that Appsync function. Okay.
Yes, sir.
Anish?
Yes, sir. I'm doing sir.
Wes, could you please explain why are we connecting? I've copied the connection code for defining the data source. What is the requirement? Why are we doing it?
Yes, sir. Yes, sir. Actually, what we are doing is that first we create the API, and after that we create the Lambda function. So in the API, we we tell that where is the GraphQL schema is based, so you can create an API. After that, in the Lambda function, we are telling that where our function is specifically defined. So to connect those with each other, we have to create a new function which will create a API.add Lambda source. So in the API, we are telling that you are we are giving you a Lambda, which is the source of the API. And in this, we are defining our Lambda function, which we have just created to connect each other.
Okay, now both of them are connected, but one thing is left. We have not defined the resolvers.
Yes, sir.
What is the function?
Because after we have joined this, what will this task will be done? How this will be done? Like how we call our function. So for that, we have to create our resolver.
Anish, I have copied the resolver, first resolver for the query.
Okay, sir. And we will need to put these resolver after our construct.
Yes.
Yes, sir. From line 30.
Okay, this is the Lambda constructor that says that the API add Lambda data source has been added to the Lambda, and this connected with that one. So both are connected, and now both are available in the Lambda data source. And now we are going to create our first resolver, which is that is.
Now, Wes, could you explain where this get to do's came? From where are we copying it?
Actually, what the Lambda, actually what the resolver is doing, it will go to the main file and check if there is any query and if there is in field name of get to do's. So if it gets the get to do name, it will fire the get to do function from the Lambda function we have just defined on the main.ts file. So it will check here and go to the main Lambda and check if there is a function, it will trigger it and perform your desired action.
Actually, it is going and checking the schema.
Yes, sir.
Open the schema, Anish. Look at this, get to do's. This is a query. You are just defining it. It is connecting from the schema to the CDK. That's what it is doing. Then let's do the mutation one.
Okay. Sir, we have to declare mutation one by one.
Yes. Now, Wes, could you explain this? What is this mutation? And
as sir explained previously, it will again go to the schema and check if there is any mutation defined with the name of add to do or not. If there is add to do mutation defined, it will trigger it and perform the add to do action on our CDK.
Exactly. Now we are not going to discuss in detail. We are just going to copy the next two mutations. Delete to do and update to do.
Okay, sir. Okay, so we have a resolvers almost all ready.
Johnny's, before we go forward, let's revise. First we created, go up.
This one.
No,
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 no.
on the left.
In the CDK library.
Step 4 TS. In the lib
I'm a
folder.
step. What are we in the code or something?
In the stack,
Sir,
step
just
4-stacks.ts in the library, in the lib directory.
click on the second tab if you didn't find.
Yeah, is it right?
Yes, let's revise it. First, we defined the APIs, as you can see. Where, Anish, did you define the API? Highlight it.
This API.
Yes.
Drift GraphQL.
Yes. Then we defined the Lambda function. Then we define the Lambda function is the data source of the APIs. Could you highlight that? Then we define the four resolvers. Now, what we have to do is, now we have to create the table. I just send you the code for defining the table. In that table, we are saying that there is only one primary key, which is the partition key.
And in the partition key, we are defining the name of the field and the type of the field.
Exactly.
As sir just copying this, I just explain the further code. After we
Yes,
define
I
our
didn't
table,
install and import Dynamodb stack.
yes, sir, you have to import it and install it also. So there is no error. In the meanwhile, sir is installing it. I just explain the further step. So what we have done, we have created the API, we have created our Lambda, and after that we have connect our Lambda and API with the Lambda source, and we create our create resolver too. After this all, we have to do something so that all the data can save in our database. So for that we have to create a Dynamodb. So before that we have to create a Dynamodb table. In the table we define the table name, the partition key name, and the type of the partition key. After we define all that stuff, what we're going to do is grant the access to our Lambda source. So our table will know that you have the access to save the data to the database. And after that we will add the environment table and give the table name, so it can be easier. In the function we have just defined the process.env.table name, so we can, our function will identify that what table we want to what function we want to save in our database. As sir continue the code, you will understand that.
Yeah, I have right spelling bad. So
let's just do this. I'm just copying it.
actually, this VS Code does not support, I guess, copy paste. I have to right click and save code. Okay, so now I need to import that. Okay, boy. AWS Dynamodb. In the terminal, Control C, Control V are not working. Okay, and take is DDB. Now it should work now. Mhm.
Now what we need to do is give Lambda function the access to the Dynamodb table database.
Okay.
I just send you the code.
This would be a part of this construct. Is that
Wes,
right?
could you explain this? What is this? What is what are we granting permission?
Actually, we are granting permission to our table, so it can perform the task which we have just defined in our resolvers. So it can save your data to the database.
Exactly. Now the problem is, in the Lambda functions, we do not know the name of the table what we have created. Therefore, if you, Anis, look at Navez's code, basically what we are doing is sending the name of the table to the Lambda function and setting it up in the environment variables.
Okay, makes sense. So because in the to-do's table, this table won't work. This name won't work. You want to say?
And this will not work. AWS has created its own name for the table.
Because in the function we have defined that you have to pick a table name from the process.env. So we have to define it here. You can copy the code from chat.
Okay. Is this right enough? To-do lambda add environment edit. To-do table name.
Yeah, what we are doing is that we are just telling our Lambda function that add the environmental variable and give it the name to the to-do tables dot table name. So it will save the table name in the environmental variable and call it on the function we have just defined in the function folder. That's
Now,
it, sir. You can deploy it, Ithra, or do you want to print the
Anis bhai?
Yes.
Could you go to the functions directory and just check add to do? And if you can see, where did we get the name of the table? From the process.env.todo_table.
Yes, sir.
This is in the CDK, we have passed it and we are getting it in the Lambda function. At runtime, it will get the table name at runtime.
Okay.
Now we just have one thing left. Let's print the different variables. I'm sending you the code. We are printing the API, the URL, the API key, and in the region which will be deployed.
In the next class, this API print will help us to connect our application to the Apollo client.
Yes.
I will be comes.
Before sir you
Oh.
deploy, please build it.
No, we
again.
don't have enough time. We have already gone past. What we
Yeah.
are going to do is just go to the command line, Anish.
Okay, wait a minute, sir. But what about adding the last thing again in the stack?
Yes,
Yeah,
on the comments.
yeah, here.
Yes.
Yeah, fine.
I think the comment is a problem. You have to put 2 backslashes. Yes. Everybody can see that what we are doing is printing the URL, printing the API key as well as the region. We don't have time to deploy it, but we are going to show you the command to do it. We are just going to say on the command line CDK deploy. That's it.
Yeah, before you guys deploy, make sure that you run the npm run build or tsc file, so everything is perfect, and after that deploy it by the cdk deploy.
npm run build first. Anish,
Yeah.
cancel this command and first run the build. Yes. And then we'll just say CDK deploy. We don't have enough time. I just wanted to tell everyone. And the next classes, this BootCamp 2021 is the server-side development course. We are not going to cover client-side. We are just going to tell you the different options. The videos are already there in BootCamp 2020. We had all the client installed. So therefore, we are going to talk to you in the next class. Thank you so very much. Bye-bye.
Allah Hafiz.
Sir, can you tell me? Sir, can you hear me?
Yes, I can hear you.
Sir, I think we have very strong grip on the object-oriented programming for the AWS. Is that correct?
Would you repeat the question again?
Sir, have you? I think we have a very strong grip on the object-oriented programming. Is that correct, sir?
Yes, that's Bilal correct. That's why we covered TypeScript in the beginning.
Exactly, sir. Thanks a lot, sir. Thanks.
Okay, thank you. Bye-bye.
Finally.
But actually, there was a little bit error.
Yeah. So yeah, that's it. After the CDK deploy, your stack will be deployed
So I
on the
need to
AWS.
run. So I need to run just CDK destroy.
After that, if you want to destroy, you have to just write CDK destroy.
Okay.
Okay, sir.
Okay.
See you
Thank
in
so
the
much,
next
everyone.
class. Allah Hafiz.